Good afternoon, my name is Ben Lewis. This is my lab, more comparison of recorded motion with simulated. The purpose of this lab was to prove that a projectile, when assuming no drag, will have a constant acceleration in the y direction, downward, magnitude g, and a constant velocity in the x. This, however, will not be the case in the observed data since drag was not negligent, as you'll see in the free body diagrams. To do this lab, we used a ball of paper, a meter stick, camera, and tracker software. Paper ball was tossed, and then we recorded that and uploaded it to Tracker as an MP4 file. I chose the meter stick as the calibration stick, set the ball as point mass A, and then clicked on the center of the ball in each frame of the video, and then observed the resultant data and graphs, plugging that into Excel. I declared the initial velocity of the ball as 1.86 and 2.29, and a drag coefficient of 0.001 from just guessing and checking. Then wrote an fnet expression of fnet is equal to fgrav plus fdrag since it's always negative. Then use the velocity update equation of vf is equal to vi fnet divided by m times delta t. And then the position update equation rf is equal to ri plus v times delta t. Then just ran the program and observed the resultant graphs and data points. And if you pay attention to the code, I did have to exaggerate a couple of these arrows just to show that they were actually, being generated and weren't getting hidden by the ball. Anyway, so the resulting graph is significantly different between all three. However, if you pay attention to the simulated, they do in fact show that, with drag, the ball with drag did not go as far as the ball without, which is standard. However, when you compare that with the tracker data, and if you look at time, distance, the ball with drag does in fact go the same distance in the same time, however, seems to have a clip downward faster compared to the tracker data. So as a result, the paper's ball behavior somewhat matches the simulated projectile motion and illustrates the non-negligible effects drag through its maximum x distance. However, the ball fails to mimic proper y behavior of a projectile even with drag, indicating a possible difference in the direction of the drag force. As you can see with some of the tracker data I pulled, the initial acceleration in the y is less than gravity. So there's a couple possible things that happen. I'm fairly certain there's a chance either A, I didn't quite see the hand still touching the paper, or there was just an air current in the hallway creating this opposite direction, F drag, and hovering the ball. Blurriness of the video played into that, and also could have been get the guess and check with the drag coefficient, and also just Googling the weight of the paper. They asked if you could find terminal velocity with this lab. That's probably not going to happen with this one. You would need to have dropped the ball from a much more significant height, and would have been also helpful to know the actual mass of the paper. But the what if question, ball was thrown straight up. I took that to mean the initial magnitude and not just the vertical component. So obviously the ball would reach a higher maximum vertical height if we're taking this magnitude and just shooting it straight up, because simple as this is greater than this. So with a greater initial y velocity, it's going to go higher than something with a lower. Anyway, thank you for your time.